Origin's Design of Experiments app allows users to design experiments, fit models to collected data, and identify the best factor settings to optimize responses. In this video, we will explore two types of screening designs, the Plackett-Burman design and the definitive screening design, or DSD. During the initial design stage, investigators often identify many factors that may influence the response variable. In such cases, it may be impractical to run a full or fractional factorial design. Instead, a screening design can be used to identify the factors that have the most significant effects. The Plackett-Burman design is a cost-effective approach used to identify the most important main effects. This design is appropriate if you can reasonably assume that two-way interactions are negligible and quadratic terms are negligible, implying that any curvature in the response is minimal. If these assumptions do not hold, a definitive screening design may be more suitable. DSDs require only a small number of experimental runs, but they use 3 levels for continuous factors, allowing the detection of curvature in the response. Despite the limited number of runs, this design can estimate main effects, as well as some interaction in quadratic terms. Our first scenario is one in which the Plackett-Burman design is appropriate. A company is producing a new gluten-free bread and has identified 11 factors that may impact loaf volume, amount of rice flour, tapioca starch, xanthan gum, yeast, water, and oil used, the mixing time, proofing time, and baking time, the proofing temperature and baking temperature. The company is interested in conducting a screening experiment to identify the most important main effects. They believe that most of the factors act independently of each other. Any interaction effects will be investigated later using a fractional or full fractional design. The first step is to create the design. Open the DOE app and click on Create Design, Factorial Design, and select Plackett-Burman. Click on Display Available Designs to explore the number of runs that are required using a Plackett-Burman design. With 11 factors, at least 12 runs are required. Enter the 11 factors along with their low and high values. Click on Settings. Make sure the number of runs is 12 and the number of replicates is 1. Click on Miscellaneous. The option to randomize the design should be used for a real-life example, but for the purpose of this tutorial, turn this setting off. Click OK to generate the coded design and design table. Enter loaf volume data under column P in the design table. The next step is to analyze the design. Click on Analyze Design. Select loaf volume as the response variable. At the screening stage, the goal is to identify the most important main effects. Click on the plus sign next to the model terms. Only terms up to order 1 are included in the model. Click on Stepwise and under Method, select the stepwise approach. Under Plots, add the fitted plot to the predefined list. Click OK. 8 factors, excluding tapioca starch, show significance at the 5% level. Our second scenario is one in which the definitive screening design is appropriate. Several months ago, the company identified 6 factors that may impact loaf volume for sourdough bread. The collected data are available as a worksheet in Book 1, and the company is interested in conducting a definitive screening design to identify the most important main effects, along with any significant interaction in quadratic terms. The first step is to create a design table for the collected data. Open DOE and click on Define Custom Design, and select Definitive Screening Design. Move all factors into the Factors column on the right. Factors are yeast, sugar, water, mixing time, proofing temperature, and baking time. Click on Low/High to make sure the low and high values for each factor are accurately identified. Click on Designs and identify the variables for run order, standard order, point type, and blocks. Click on Response and select loaf volume as the response. Click OK to create a design table. Design-related variables and exploratory variables are highlighted in green. The next step is to analyze the design. Click on Analyze Design. Select Loaf Volume as the response. Click on the plus sign next to Model Terms and select the full quadratic model. Click on Stepwise and under Method, select the stepwise approach. Keep alpha to add and alpha to remove as 0.15. Under Plots, add the fitted plot to the predefined list. Click OK. Under the stepwise method, we define the alpha to add and alpha to remove as 0.15. The results window shows that all 6 factors and 2 quadratic terms, yeast times yeast and water times water, met these criteria.